understand that everything that I'm going to be talking about here, for no matter what it is, it's all technology that already exists. The fuel that we're going to get, the going faster than the speed of light, is all technology that already exists. Now let me tell you something about warp speed. Okay, first of all, it's not going to be possible for you to ever warp the fabric of space with a machine. Okay, you're going to only be able to do it with mass. And if you try to do it with mass, what's going to happen when you fly by a planet? You're going to rip it apart. You're going to move it around. Because the gravity is going to affect that planet when you fly by it. You're going to fly by a sun. It's going to suddenly spill out its contained explosion out into your warp bubble. You're going to rain comets down. You're going to do all this crazy stuff. And I don't believe that warp is necessary or that it's even possible. And also, why wait? Because everything I'm going to talk about is technology that already exists. Now, first of all, I shouldn't eat while I'm talking. But secondly, the fuel. Okay. Chemistry 101 says that all gases compress and that liquids do not. So we use liquids in hydraulics because they don't compress. The liquid will push the orange up, as it pushes, because it doesn't compress down from the weight, right? Simple. Gases, the molecules are super far apart from each other, and when we use the process of compression, we can squeeze them together, sometimes until, they even turn into liquids, or whatever, you know what I mean? Like, who cares if they turn into liquids, or not? But, I assume that they can at some point, that doesn't matter, but, anyway, all gases compress, okay? So, an air compressor is technology that already exists. And it's also the thing that we need to look at when we're thinking about putting the amount of fuel in space that we need to go those multiples of C to reach other planets. Looking for the resources in space for fuel, we're going to look at the gas giants. We're going to look at planets with dense atmospheres. But we do not want to try to do what I'm going to talk about on a heavy gravity planet. So something like Jupiter is out of the question. I had no idea that Neptune was only 1.1 Earth G. So I wasn't looking at it, and I haven't gotten much information on it, but it's got a gas atmosphere, and it's possible to do that with it as well. Now, looking at the volume of a planet like Neptune, you're talking about an unbelievable amount of vast fuel resources that you can compress, as long as you can do it in the freedom of space. If this is Neptune, then I can hang a fuel rig, an oil rig, over it with a line that goes down into its dense atmosphere and pumps the gas, compresses it, pushes it up the line, and fills the fuel tanks above it. Fills them up. Boom, 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 boom. Right? Now how do I do that? You got 5 roughnecks on a rig. You got the worm that's down there in the hole. You got the roughneck that's screwing the pipe. You got the mud guy that's mixing the lubricants. You got the drill operator that's pushing the buttons and commanding the crew. Okay? All these things we have to automate in space. But luckily in space, we're not trying to dig through the earth. We're not trying to dig through a solid in this concept. We're trying to dig through air. Beautifully and simply, we're trying to dig through a gas. And just simply to suck that up and compress it up into our rig. So what we need most of all is the ability to have the pipe screwed together still as it lowers down. We need a satellite that looks something like a cylinder, right? Filled with all these pipes, just like we do on an oil rig, and an auto roughneck that screws them down, and we're lowering it down one by one by one by one down into the upper atmosphere or wherever it's dense enough for us to begin to compress the gas. Now on Neptune you got supersonic winds. On Venus you got CO2 gas, and it's close enough to the sun to use solar power. It's I think it's only 0.6 Earth G, but it's got hydrochloric acid. It's thousands of degrees on the surface. It's got supersonic winds, I think, and it's got like 2 cyclonic eyes at the top and 2 cyclonic eyes at the bottom, where there's no winds whatsoever in the eye of the storm. But your satellite has to rotate. So how do you get it to stay there so that the winds don't pull your rig down and crash it? So this is a winds engineering problem that we have to come up with, that we have to solve to figure out how to pump the vast amount of fuel we need to be able to go multiples of C. Now, when we're talking multiples of C, if we can go 1 C, we can get to the sun in 7 minutes. I was writing some people, and I broke it down. You know, I kept dividing it. Like, I started from light speed, and then I kept dividing it down to where, like, I could, you know, how much fuel would it take me to get to, or how many P would it take me to get to the sun in 24 hours? So it's 7 light minutes to the sun. So how many P would it take me to get to the sun in 24 hours? So what I need to know is my thrust, right? I don't know that. So just throw whatever number you want in, and you can figure that stuff out for yourself. Because it's a simple equation. Okay? But now, getting back to where I was, and I forgot exactly where I was. Oh yes, the winds engineering, right? The winds engineering problem, I believe, has been solved by, thank God, a higher power of inspiration, that we can attach an aeroplane foil to the compressor at the bottom. I was thinking that it could just be a compressor, you know, like a standard, like, or a box, a freaking box that floated so many hundreds at a certain height above Venus's surface. It's 72 degrees, and this is above the hydrochloric gas clouds, and you still have all of your you still have enough atmospheric density to provide you with enough to you know, compress gas. I think. Now, all this stuff is like an engineering problem, but that's why I called my book The Executive Outline, because this is stuff that engineers have to figure out. Okay? This is an executive outline. This is just the executive tells the engineer, do this, here's your problem, do it. Alright? That's what it's called. The executive. It's not the engineering outline, it's not the technical details outline. Okay, so anyway, what I think we can do is float a rig over Venus, lower that line down, use an automated roughneck, and I've been calling it ORCS, O-R-C-S, orbital compression system, right? Orbital compressor system. But so our rig, and it's solar powered for the compressor, and so if you can imagine just lines and then like a tube here, you know, or a valve here where each tank is attached and then fills and then is moved over to a staging area by an RSDV, remote staging and delivering vehicle. Just a drone or a robot, you know. Its job is to attach each empty tank and then move the full ones into a net where it can then ship them off to the earth. So you got your solar power, you got your line coming down, you have your valve and where your tanks are placed. Now at the bottom of your line, and it's got to be a long line, understand, it's got to be a long line. So it's got to be something, maybe a rack of cylinders of lines, you know. But we could do it the same way we do an oil rig already, because I want to use technology that already exists, because it's tried and true. Now, so compact compression tubes, right? So, and then at the bottom, an aerofoil that's going to constantly give us this lift in the winds. So, you know, the aerofoil is going to lift constantly as the rig moves over the planet. Now we have however many full tanks of fuel that we launched into space when they were empty, and we have massive renewable energy supplies in space. We can use those to spin fire artificial gravity decks. We can use them to power turbines. But there's a better way to power turbines for electrical production. And solar power is never, ever, ever going to help us when we get past Jupiter. Look up a chart of solar power depletion as you go through the distance from the sun. It just drops off. You have no more solar power. You got no running water, China. You got no running water to help you make nuclear powered spacecraft like you're talking about. Where's a nuclear powered airplane? There ain't one. There's only nuclear power ships because nuclear power needs all that water. Alright? So China, quit telling us you're making nuclear powered spaceships. You got nothing to make steam out of in a vacuum. It don't make no sense, man. Alright? We know it's BS. I'm not trying to pick on China, but look, it's not going to happen. Anyway, solar power, nuclear power, these things aren't going to work. Running water, these things aren't going to work. What we have to do is we have to figure out how to make a dam in space without the water. And I figured out a way to do that. That's the next video.